Can you guys hear me okay? Is this better? Okay. Before we begin, is there any current or former SaltStack employees in the room that are not helping me present? Yeah, you guys can leave. I don't want you critiquing my slides or my code. All right, so this is SaltStack for developers. My name is Gareth Greenaway. This is my co-presenter, C.R. Oldman. There's our GitHub and our Twitter accounts up there. They're also on the Twitter accounts are on every slide, so if you feel like tweeting at us during the talk, feel free. And this is SaltConf17 in case anyone was lost. Okay, so quick agenda. We're going to be talking about just some ways to involve developers within your organization to use and utilize and get benefit out of SaltStack. So we're talking about writing custom modules, and then of course deploying those custom modules. Then CR is going to talk about a tool that he wrote called STC. We're going to also talk about development of salt states using Docker containers. And then finally, we'll look at using salt environments to maintain version salt states. Okay, so just a couple tools that I recommend, and that both of us actually recommend. So the first one is if you're using Vim for any of your salt states, your pillar values or whatnot, there's Salt Vim, which will give you highlighting and all sorts of cool, nifty stuff to make sure you get your pillar values and your state files right. There's also a plugin for Sublime if you're using Sublime. And if you happen to be using Emacs, there's Salt Mode. The fourth one is a syntax highlighting and lint plugin for Vim. I highly recommend it. A little side story of why I love this one so much. My first contribution to Salt, I believe, still holds the record for the most lint errors, somewhere in the neighborhood of like 500. Colton, does that sound about right? Lint errors, my first contribution to Salt State? Yeah, okay. So if anyone feels like breaking it, my record, don't use that plugin and submit some code. There's also Barnacle, which was written by Mike Place of SaltStack. So it's a really good tool for testing custom modules, testing states, testing all sorts of things across distributions using Docker. And then some debugging tools. So there's PyCharm, the professional edition PyDev, WinPDB, which we weren't sure if was still maintained or not. It didn't seem like it was. And also a plugin for Visual Studio if you're using Visual Studio. There's a couple more that didn't make it on the slide because I just remembered them this morning. There's also Kitchen Salt, which was mentioned in the keynote. Did I hear a woo? Awesome. And there's also PUDB as well as the Python debugger. Okay, so custom modules. So you might be asking yourself why would you want to use custom modules? So there's a variety of reasons. So current counts, I should jump ahead. So these are the current counts of available modules, including beacons count, clouds, engines, grains, states that we currently have in the open source project. So a couple that I wanted to highlight because they're kind of the commonly used ones. Were modules, so there's currently 481 modules, and obviously these aren't supported across all systems. It depends on what you're running. And states, there's actually 317 state modules. But obviously these aren't going to cover every single use case. So if you use a particular application or you have a particular network device or whatever, if it's not commonly used, chances are it's not going to be in this collection of modules or states. So a couple execution basics. Actually, before we go on, one additional use of why you would want to use a custom module. How many people are running a unsupported version of Salt at the moment because you can't upgrade? So how many people really want to use the latest features in the newest version of Salt, but you can't upgrade your version of Salt? I saw 1 or 2, 3, 4. Okay. So using custom modules, using the methods of custom modules, you can actually pull the modules down, providing they're supported, and use them in your existing legacy, older, unsupported version of Salt by installing them and using them. Okay, so a couple execution module basics. So every module should have, even though it's optional, it should have the virtual function. It's definitely best practice, not required. So it's actually executed when the Salt minion starts up and provides identification for the name of that module. So if you have a module named, a specific module for installing packages on Debian, for example, when it loads up, it will have a virtual name of PKG. So you use the same module on your Debian machine as you do on your Red Hat machine or your CentOS machines or your Fedora machines or your OpenSUSE machines. And they're also commonly used whether or not that module should be loaded or not. So within the virtual function, you'll have some sort of check whether or not a specific Python library or a specific case is met before it loads that module up. And one of the new features actually in 2017.7, you could provide virtual aliases. So you could have your module have multiple names. A good example of this was the Docker module. So originally there was a Docker module and then Docker changed some things and so that required the Docker ng module. So in the later version, the 2017 release, there is the Docker ng module, but it actually references both Docker and Docker ng using the virtual aliases function. Can you guys hear me okay if I put it here? No. No. Damn. All right. All right, so there's also private functions. So private functions are always going to start with an underscore. And they're only used for internal use by modules and will not show up using sysdoc or any of the other documentation related functions in the sys module. And then we have our public functions, and these are the calls directly to Salt. So if you're calling them on the command line or you're calling them within your states, these are the functions that you're calling from the specific module. So a good example, going back to the PKG module, PKG install is the public function. Okay, there's also support for logging. So it's a typical kind of example of using logging. So import the logging module, set up the log variable, and then depending on what your use case is, these would be the log functions that you would use. So if it's information that's useful for the user running the module, you would use info, and so on down the list. And doc strings. All of your modules should have doc strings, including the functions. That way, if someone needs to go back and look later of what your function does or your module does, they can easily use it through sysdoc, or if you end up contributing it to the open source project, it's available on our documentation. Okay. Oops. So we'll look at a couple examples of some custom modules. And all of the code examples that I'm using will be at that GitHub URL, so you don't need to scramble and quickly type it down or take pictures. All right, can everyone see that okay? I'll take that as a yes. Okay. All right, so here's a very, very simple example of a Salt module. So at the top we have our encoding, so UTF-8. There's our doc string, so a very simple module to give a greeting. Next line is the from future, so make sure that we are Python 3 compliant. There's our virtual name, so when this module is loaded up by the Salt minion, its virtual name will be hello. Coincidentally, it's the same name of the file. There's our virtual function, so we're not doing any sort of checks, we're just simply returning the virtual name. And there's our function world, so, and with a doc string, say hello. So if we run that, well, first of all, install it. So anytime you're doing any sort of custom modules, so modules, for example, go under, by default, SRV salt _ modules, beacons, states, engines, etc., all go into their appropriate names beginning with an underscore and that default location. And then to well, it's even difficult with like dozens of people looking. And sudo. Okay. So in order to install the module, I typically use sync all. There's also refresh modules. Depending on what you're installing, what you're using, there is an equivalent function for that. So there's refresh states, there's refresh beacons, but I always default to sync all, and that will sync everything. So we can see here from the output that it's copied the module, my custom module from SRV salt _ modules into the salt cache, and it's telling me it's now available. Yeah. And if I run it, we get a simple message back saying hello world. Looking at something a little more complex, it's just a simple module that I put together in a couple hours after a conversation with CR. So again, it looks very similar to the last one. There's our encoding at the top and our doc string. And then we're importing some modules. So we have the one to make sure we're Python 3 compliant. We've got logging, we've got the OS module, and we've got the PWD module. And then salt utils. And then the exceptions in case anything goes wrong. So there's our example of setting up logging. There's our virtual name. In this case, it's just desktop notify. And this time our virtual function looks a little differently. We're actually doing a check to make sure that the binary notify-send is available and installed. And the moment you install salt utils, this function is available to you. And so if notify-send is not available, it's going to return that string false, not available, or not installed. And so then we have our public function, send. So it takes a series of arguments, including some keyword arguments that are not specified. So we have our user, our summary, our message, and then as I said, the keyword arguments. So there's our doc string, just gives a quick example of, a quick description of what this function does, and then a command line example. And there's our return string, so once the module runs and then returns, this will be the default return that the module sends back to the user. So in this case, it's a default comment that I obviously didn't update that says unless execution is succeeded and result is true. So then we do a try except to see if the user exists. So this is using the PWD module that we imported earlier. If the user doesn't exist, it generates a key error that we catch in the accept and just log a message and return that the user doesn't exist. So then we're setting up a dictionary that we call environ. Grab the user's XDG runtime directory, or what the directory should be. Grab using the isdir function within OS path, make sure that that directory exists. If it does, we run this chunk of code. If it does not, there's where our exception handling comes in, and we raise a command execution error telling the user that they're trying to specify doesn't exist. And then the rest of the if block, we just check for various arguments. Yeah. Go for it. That is a good question. That is a typo. Yeah, thank you. Yeah, that should be virtual name.
And rolls outside.
Yes. Or a bacon-topped donut. Salted bacon-topped donut. All right. Any other questions while I go? I should have said beforehand, like, I checked with CR beforehand, and neither one of us mind if people interrupt during the presentation with questions. Sure.
Because if you return that tuple, then the true or false tells the loader if it was successful, and then the string afterward actually gives you a message. So in previous versions of Salt, you'd have modules that wouldn't load and you wouldn't know why. So we added support in the loader so that the message and the second part of that tuple will show up in your log.
But you're not using it like down below where you have something equals.
Those returners are different, or the return is different. So in the virtual function, it's returned, as CR said, it's a return to the loader. The return in the public function is actually returned to the user. Any other questions? Okay. So then the rest of the code, we're checking for the keyword arguments. So in this case, I'm looking for urgency, expire time, app name, icon, category. And if they exist in the keyword arguments dictionary, then I just kind of continuously populate that command string. Yeah. I could, yeah. I don't fully understand how it works. I'll leave that for CR. You're welcome, CR. All right. So once we have our command string populated, we make a call out to the cmd run all module, passing in the arguments that we've collected over the course of the code. So we're passing in the cmd string. We're using the run as argument to run it as the specific user. We're passing the environment, so that grabs our environmental variable there. We're using Python shell as false, and then we're returning based on what the result is. So if I run it, again, copy, service salt. Okay. Run our sync all again. And it's actually not outputting because I've already copied it over there. And nothing has changed recently. But if I run it somewhere here, okay. So there's an example of me running that module. In this case, I'm passing local, just so it doesn't talk to the master or the minion. I'm passing the first argument is my name, because that's the user that I'm logged in here. I'm just passing this is the subject argument, followed by the message. The urgency in this case is low, and with an expire time of 3 milliseconds. Let's actually bump that up a little bit. So when I run it, it'll actually pop up a little dialog box up here and using the binary notify.send. So, like I said, silly little module I wrote. Okay. The third example is actually one that I stole from one of our solutions engineers that he actually used with a customer. It's another example of using a little more complicated than the last one, and actually using another example of using a existing module. So writing a custom module to call a module. So in this case, We're setting our encoding, importing the future, the absolute import, so we're Python 3 compliant. Importing date time, setting our virtual name of schedule test, and making sure that in this case in our virtual function, making sure that the schedule.add is available as an execution module. And of course, returning the right virtual name. So here we have our sched function, our public function. So there's our doc string, there's our command line example. We're generating a time, a date time, pulling out the various bits and pieces that we want for year, month, day, hour, minute, and second. Figuring out the time to run, which is based on minutes further up, and then actually calling the schedule.add with those arguments. So what this will do is call a specific, or actually set an event on the event bus, on the Salt event bus, to run an arbitrary command at a specific time. It's always going to return true, yeah. Even if it fails, it will, yeah. Not my code. All right. Okay, at this point I'm going to turn over to CR, who's going to talk about his portion. You want to plug in, right?
I often wonder if when the Google engineers were putting together Google Slides, if they thought about the use case of two presenters editing each other's slides during the actual presentation. It seems to work okay. All right. No, I'm good, thanks. Okay. Blink. How's that look? Yeah, not too bad. Forward, back. Hey, it's my lucky day. So this part of the presentation kind of came out of a couple of things that I sort of collected over the past few years about using Salt as a developer. And it's one of those things where it's not really enough to warrant a whole 45-minute presentation, but boy, are these things useful to me anyway. Maybe they'll be useful to you too. And I kind of titled it Bringing Salt Down from the Clouds. So, there's tons of powerful programming utilities inside of Salt. There's an awful lot in there, even just as a development environment. And we combine all that with the power and ease of use as Python. And I like to think of the analogy, it's kind of like a regular screwdriver versus a cordless drill. If you could do all that stuff by hand, but I'd actually had to do some maintenance on my deck a couple of weekends ago, and boy, am I thankful for that cordless drill. It turned what would have been an all-day job into a couple of hours. And the other thing I've been considering a lot of is, that's a typo in the last bullet point, I don't know what I meant there, is if you're a developer, so let's say you're a DevOps person, you use Salt to deploy stuff. It would be kind of handy if all your developers knew Salt, right? Because then as they build out these applications, you get ready to put them in production, then you kind of speak the same language. So would it be useful to kind of get developers to use Salt during their development process? And that's what I've been doing in a couple of projects. I wrote this little tiny shell script. It's like 8 lines long, called SDC, which is short for Salt Developer Call, Salt Call for a Developer. And I'm going to show you what that looks like. It's a tiny shell script that lets you leverage Salt in your in development. It works with, there's an environment variable called SaltConf17, which is the same thing as -C on the command line, and then a file watcher like Watchdog in Python. And so you set Watchdog to run SDC when certain files change. Next. There we go. So I'm going to show you a quick example, which involves a traditional Django application, a virtual event inside a virtual env, masterless Salt, and the watchdog file watcher, and then I created this isolated configuration file tree, so everything that Salt needs actually goes in a directory inside the project directory. So when you run Salt, you're not messing with maybe your system's installed version of Salt, or if you happen to have a machine that's connected to a master somewhere else, it doesn't matter. So we put that file tree inside the directory, and let me bring that up for you. And you can see what it looks like, and I'll show you how it works. And bring the font size up here. Ooh, too big. Let's try 28. That's not any better. There we go. That's reasonable. Okay, so this is all there is to it. I source the activate for the virtual end, and then I call terminal notifier just to give me an indication of what's going on, and then I call salt call with whatever command, and the -q is for quiet. So if you don't want any output, if you just want to run whatever and return, then you say -q. Otherwise, you obviously get all the output, and then at the end, depending on whether or not your return value is 0, you pop up another terminal notifier message so you know what's going on. So let me show you what this looks like. So inside my virtual end, this actually, just for the sake of clarity here. So my family homeschools. We've homeschooled all of our kids. So. Woo, I didn't expect that. And my wife got really involved in leadership in the homeschool co-op. And one day she came to me and she's like, this scheduling thing, it's driving me crazy. And I said, well, I can fix that. And thus began a 6-year-long fiasco where I built this website and whole scheduling system in here, courses, all sorts of reports, and obviously, it's a real application. I have to spend time maintaining this thing. We've got about 50 families and about 200 kids in the co-op, and they meet once a week. So this is the packages SLS for that application. And as you can see, I've got a couple of regular packages, Python 3.6 and the pip and pip for Python 3.6, and then all of these modules that I use in the application. So I use the pip installed state with bin-env to point to the right version of pip. And the idea would be that as I'm developing, I'm like, oh, drat, I need a new package. Let's see. Oh, let's add LDAP support. So inside, we run watchdog, or watchmedo actually is the name of it, and it sits there and watches all the files. And so let's add LDAP. And when I save this, what's supposed to happen is, it says, yeah, running high state. So I don't really need to think about doing the pip install. It runs the high state. This takes a few seconds because pip is actually, oh, that's why it didn't show up. I turned on do not disturb, so you didn't see the cool little notifier. Okay, there we go. Succeed. So if you guys have used, the green-red test-driven development stuff, that was where that idea came from. So let me just run high state whenever I make those changes. So I point that at all the packages, the SLSs that have the packages in it, and then if you're familiar with Django, you know that there are a bunch of settings files, and I use this pattern where I put the settings in a directory, so they end up in an isolated package, and I've got a development setting, I have common, which all the other ones insert, I have a staging, and I have a production. So watchmedo is also watching those files. So if I go in and I edit, for example, the production and say, I'll just put a comment in. Same thing happens. So I go template that through Jinja. It picks up this file and goes ahead and writes it to where it's supposed to go. And truthfully, this has been really handy because one of the things that it gives you is, since I use that stuff while I'm developing, then I have a whole set of states that are almost ready-made when I get ready to go deploy. And that's where the idea came from, about if you got your developers involved with using Salt during the development process, then the deployment process becomes a lot easier. So the second thing I want to, any questions about that? Go ahead, Ed. You set all that up within the Watchdog configuration file. So you can define some dependencies or a timeout to wait so that you're not continually calling the process. So, and you can use any file watcher. Right, yeah, like all the stuff in my, in the source code directories, it won't call for there. Really just the SLSs, the config files that I keep in serve salt, those kinds of things. Any others? Okay, so second thing is Docker, right? Everybody uses Docker nowadays. It's like kind of the, well, I was gonna say the new hotness, but it's not that new anymore. So this was another idea came up with regarding, you know, if you're gonna develop inside a Docker container, but you like Salt, you know, what are you gonna do about that? Because you've got your Docker file where supposedly you're supposed to install all your dependencies, all your packages, you know, you're supposed to set up this container so it doesn't change, those kinds of things. But I've already done a lot of that stuff when I was developing the app using this other little tool. So I set this up so that, let's see, I wrote this slide a while back and I'm trying to remember what I was gonna say. Well, let me just show you the Docker file. That's the quickest way to do that. There. So in this case, the Docker file becomes really short because I've just got the from clause where I grab whatever OS or whatever distro I'm gonna use. I do the updates, and then I install Salt from the repository, make sure my locale is all set up, and install the Salt minion. And inside there, I go ahead and copy the configuration directories and then run salt call to go ahead and set up the container. And then you're pretty much done. And then I actually do development inside that container. So it actually has an init and everything like the Docker people say you're not supposed to do, but I do anyway. And this, again, is a time saver. The challenge there is that if you're gonna do it this way, it takes a little bit of discipline. Oh yeah, there we go. Because you don't really want to install packages from the CLI anymore because then you're going to forget what you installed, right? So if you use SDC and you combine that with Docker, then whenever you want to add packages, you just add them to the SLSs. SDC picks that up, does the install for you, or if you're going to roll a new container, you can configure it that way as well. And you want to edit all your state files inside your inside the virtual environment. Salt serves Salt in there is just the whole Salt directory tree, which I can show you really quick. That's the wrong directory. So if we drill in here, so there's Salt, and then inside there's an etc, which is where the configuration file goes for your local masterless Salt. And then there's a Salt directory, which is, we'll talk about environments in a second, that has a couple environments in it. And there's a serve directory, serve Salt. Also, all these particular SLSs go in there. And then when you're ready to deploy, you just move these things to your master. And you go from there. You do actually have to have a var in here so that your Salt minion doesn't try to write to the regular cache directory or the regular log directory. They don't really do anything, they just have to exist, so the minion has someplace to go to write those things. Yeah, shoot.
This doesn't look like this stuff is on your Pro SaltConf17.
Which one is missing?
The whole Docker.
I think maybe I haven't pushed it all yet. I know I just created an example Docker file that it's supposed to be in there, so maybe I didn't push it yet. Okay. All right, and so another idea to consider is maybe you want to use environments to produce dev containers versus prod containers. That's actually kind of a challenge. I've been experimenting with that. It hasn't worked out very well yet. Gareth is actually going to talk about environments a little bit more right now. But the idea would be, let's reuse these salt states where possible, even though prod and dev, they're actually almost identical. There's just a few differences, so let's try not to reinvent the wheel, because then you forget where you made those changes, and you forget to fix them in both places, and then you deploy, and your wife isn't happy. That's not good. So, all right, I'll turn it over to Gareth. Yep.
All right. So I just looked at the clock. We have like 9 minutes left, so I'm going to go fairly quick through this last one, but I will be available after the session if anyone has any follow-up questions. So I'm going to quickly talk about using salt environments for versioned salt states. So here's a quick broken down run list of what environments are in terms of salt. So directory hierarchies containing top files and a set of salt states. No requirements that they be used at all. Most people end up just using their base environment. Works perfectly fine. The default environment, as I said, is base. It's recommended that users only create multiple environments if they have a solid use case. So what kind of prompted this portion of the talk is actually something that I did at the last place I worked. And I wanted to get the developers more involved in the Salt infrastructure because they knew the applications, they knew what was supposed to be in there, they knew the config files, and I didn't to the extent that they did. So here's a typical sorry, mind blank. Here's a typical definition of what a file routes look like. So in most people's case, if you haven't configured file routes, this is what it will look like. There's your base environment, and there's your location of the default states, so SRV salt. So here's an example of a top file using the default. So in this case, it's base. There's our targeting, in this case, just everything. And there's a list of just some states that we're calling. So in this case, one called core, one called edit. So why the concept of salt states are useful? So in most cases, come here. Linux on laptops is sometimes finicky. There we go. All right, so in most cases, when you have your code, your product, or your project in GitHub, you treat your project code as your project, or as your product. Come on. So in this case, why are salt environments useful? So here's a typical routes.conf using environments. So in this case, we have a develop environment, a stage environment, and a product environment, and they all have different locations for states. And here's our just an example of a top SLS using those environments. So in this case, it's the dev environment. We're just targeting any machine that whose node minion name has dev in the name, and there's the states that we're using. My laptop is not cooperating today. Okay. And there's another example of using, in this case, grains to target. So we're looking for any grains that have the role of web or dev in the environment, develop. But why? So how many people treat their infrastructure as code? How many people wish their organization treated their infrastructure as code? Yes. So treating your infrastructure as code allows you to, like, if in most cases, like your product code, someone decides to develop a feature, they're going to create a branch, they're going to work on that code, they're going to commit the branch, and at some point it's going to get committed into either the master or the release branch or whatever, and you're able to do like kind of checks and balances on that branch and that code. And so we can do the same thing with our infrastructure, with our salt states. So we can treat our salt environments as those project branches. How? So we're going to use, and I'm not going to go into details, I'm sure much to the chagrin of Dave over there. I'm not going to go into too much detail about the Salt API, but we're going to use the Salt API. We're going to also use Salt reactors, and we're going to use GitHub webhooks. So just a quick description of what the Salt API is. It's a network API that allows you connections to the Salt master to run commands and do all sorts of cool stuff. Salt reactors, small little Salt modules that wait for specific events and react in some manner. For example, running a specific module or state. So setting up webhooks. So that's a screenshot of GitHub setting up webhooks. So in this case, there's the payload URL. So this would be the Salt master URL that your Salt API is listening on. So we want to set the content type of JSON and just tell GitHub to send us everything, or just to push the event. And there's an example of a Salt API URL. The secret that we passed up here is just a random string that's shared between GitHub and SaltStack. We want to set application JSON, and as I said, just have GitHub push the event. Okay, so there's an example of us setting up the reactor, and we'll actually look at these a little more in depth as much time as I have. So in this case, we're reacting on the Salt Net API hook GitHub push event, and then we're running the SRV reactor net API hook GitHub push update-single.sls. Okay, so a quick demo. Hopefully it works. And actually, I'm using Docker to demonstrate this, and the Docker file and all the other stuff is inside that URL that I pasted. So if you guys want to try this out and play with it, you can. Okay. All right, so okay, so here's the example of the GitHub secret. So in this case, I just have a file in master.d that just has a random string that I generated. And I actually usually use a little binary called mkpassword to generate these strings. But it's just available in the config, in the master config. And there's our reactor again. So in this case, it's running the state update-single. And there's our current roots.conf. So in this case, I have two environments set up. One is called base, just the default. Another is called saltmaster, which is the machine that I'm running this on, or the Docker container. And there's my Salt API config. So in this case, I used the TLS module to generate those certs. I'm turning web disable auth off just so I don't require authentication when I'm hitting the webhook URL. And then I'm telling it the webhook URL to be /hook. Okay. The reactor, come here. Okay. So in this case, I'm actually using Python. So one of the things that initially I really liked about SaltStack was the ability to not just have YAML-based states and reactors and whatnot. I actually attempted to write this initially in YAML, and I think it was one of those moments where I just like threw the keyboard across the room and walked out of the house because it was just so frustrating. So I switched to using Python for it, a lot easier. So in this case, we're importing a bunch of modules and waiting for connections from GitHub. So looking for a specific header that GitHub is sending. So in this case, the X hub signature. So we're doing a split on it, grabbing the body, which is actually the body of the JSON that GitHub sends. If it's a valid key, if it matches what we have in that master config, then we run a bunch of code and pull out various variables and then do some logging. So the interesting thing is the call to local.state_SLS. So if everything checks out, we're passing a bunch of variables to the state.sls call or module with a target of SaltConf demo, passing it the argument of saltmaster get single. So that's just actually going to run the state that will do the magic. Okay. So this is the state file. So if you've used written states and used Jinja, it should look fairly familiar. So we're just setting a bunch of variables up here. In this case, I want all my Salt projects to live in /DevOps/projects. I'm making sure that that directory exists. And if doing recursive make durs just in case /DevOps doesn't exist. Grabbing the project and the branch out of the pillar values that we were passing in, making sure that they exist, and then comparing those two values in pillar. So if we look at that real quick. So this is just a pillar file that I'm including for the local Docker container here. So I just have a short little dictionary that lists my my GitHub projects and then what the URL is expected to be. And then I grab the project URL and the project target. Again, if the project URL exists, it does checks to see if that directory exists. That is going to check it out the project to. If it does, it runs a git reset, and we'll see why later. And then just does a git.latest. So one of the things I wanted to point out in here that I didn't specifically call out earlier was in order to make this work, I needed to generate some SSH keys to actually do the deployment to make git.latest run. So just standard SSH key, no passphrase. And I'm actually using the deploy key option in GitHub. So it just has read-only access to the project. Any questions real quick? No? Okay. So again, we're just doing a git latest, filling in all the variables that we created up top. And then at the end there, it's an inverse require on Etsy Salt master.d.roots.conf. And then the next line is actually using a file.copy to generate the roots.conf, or actually the top.sls files within each project that I check out. And I don't have time, but if anyone's interested, I can go into why I'm doing that later or after the session. And so then managing the roots.conf, and then restarting the saltmaster at the end. So because this is a live demo and I didn't want to risk the fact that GitHub might have randomly gone down. Never happens. Come here. I wrote a series of little just shell scripts to actually simulate what the connection from GitHub looks like. So here's the curl event. So it's just expecting a branch. So this is the GitHub branch, and then a signature that is generated based on that key, comparing between GitHub and SaltStack. And this big log ugly JSON is what gets sent by GitHub. And then there's the curl. So if I run this, first checking our salt state location. If everyone could just like close their eyes while I'm typing, this would help a lot. Okay, so the only thing over there is SaltMaster at the moment. So we're gonna simulate that I checked out my project. I created a branch called branch 1. I checked it in, did a push, and it failed. Because Salt API is not running. Let's try that again. Okay, so there's our connection, there's our curl to the API. We got to return true. And if we flip over to the SaltMaster, we can see that the call to the state and the debug messages switch over to the API. We see the big nasty JSON message that gets sent. Over to the minion, there's the call, get a little error of service restart because it's running in Docker. But if we look at the DevOps projects, we now have a SaltConf17 project over there. And we have a branch 1 that was checked out from GitHub, in theory. So that's just the code. So if I wanted to do a second one, again, like I branch a branch 2, it's very similar except I'm just passing branch 2. Now there's a branch 2. The last thing I wanted to mention was one of the things that I found when doing this, I'd always end up with just lots of branches, like as people were like creating branches and they wouldn't go and clean up, and I'd end up with like branches and like hundreds and hundreds of branches on my SaltMaster. So using the Salt scheduler and this guy, come here. It should look very similar to the single. Just basically runs through, makes sure that if any project, any branch is no longer in GitHub, it goes through the Salt environments and just cleans it out. Any questions? No? Any questions for CR? No? All right, thank you guys.